So welcome back. We identified a low risk anomaly for total risk versus average returns in Europe blue chip data. Now, over the last 20 years. Now, what we now want to do is we want to check whether the picture changes if we are using systematic risk or idiosyncratic risk or the beta, which is also a measure for systematic risk, whether we use that on the x-axis. All right, so what we now do is we are just adding information into our Pandas data frame investment opportunity set. Okay, so we are starting with total risk. Now, what we basically want to do, I even highlight that here. We have total risk equals systematic risk plus idiosyncratic risk, right? Systematic risk is the non-diversifiable risk. Idio is the diversifiable risk. And we want to do that risk decomposition for our stocks. Okay. So therefore we say investment opportunity, give me a new column, and the column name shall be total risk. Okay. And that is just inf op. Wait a minute, inf ops, interesting. I did already annualize here. Okay. I did already annualize, so then we don't have to annualize. It's already standard deviation power 2. Okay. Now give me another column which I will call systematic risk. So what's the systematic risk of a firm? For that you need some theory. Now according to the CAPM, if you add a high risk stock like ING into your portfolio, the risk that survives in the portfolio is just the covariance that the stock has with your overall portfolio. Okay. You might say, but isn't the CAPM a theory? Isn't that wrong? So on and so forth. The point is one can still show, and I think we got a video on that, if you have an equal weight portfolio and n goes to infinity, then the risk of that portfolio is driven exclusively by the average covariance that the stocks have with each other. So you see, it's the covariance risk, which is the one that survives. And that's outside of a theory. So therefore, the systematic risk will just be the covariance risk. And for the covariance risk, we need the correlation. I see. So therefore, let's just add a column correlation. So why don't I just take another cell, insert new cell. Okay, great. Now I'm first working on my correlation. Okay, inf op, how do I call it? Core 1 over n. That's the correlation of all the assets with my market portfolio. So it's rd.core. That is a correlation matrix which I get. And now I want to get a specific information out of it. I want to get that one here. So I want to get what's the correlation of all the stocks with my 1 over n portfolio, which is ordered last. That's why that's the one here. Boom, that's what I have. And now I can go back to my investment opportunity set pandas frame, and I want to have my systematic risk. Right? And the systematic risk is the covariance of every firm with the 1ON portfolio. The covariance is just the standard deviation of asset I, standard deviation of the market, times their correlation. Okay. So, therefore, let's start with the standard deviation of the market. Okay, so it's all in our pandas data frame. It's the STD column, and there we take the position of, it's a column vector, we need the last position. So it's the ilog of inf-op dot shape 0, since the counting starts in 0, it's shape 0 minus 1. Now that's the vol of the market, and we are multiplying that with the standard deviation of all the stocks, including the market, and then we are multiplying that by the inf-op correlation, which we just computed above. Did I exercise that thing? I think I did. All right. Awesome. That's the systematic risk. Well, we could also do the systematic risk ratio. I don't think I do that here. You just do that over that. It's interesting, but I want to save some time so you can see how much of total risk of a firm is really systematic in percentage points. Let me directly go to the beta. So what is the beta? Important concept in finance. Simplistically speaking, it's just the slope coefficient from regressing excess returns of a firm onto the market excess return. CAPM theory-wise, it's the common co-movement that the individual firm has with the overall market. So it would just be covariance, asset I, asset M, which is our systematic risk, divided by the systematic market risk, which is just the systematic risk of the 1/n portfolio. So that should be straightforward. We compute the beta of every firm, and the beta is just the systematic risk divided by the systematic risk of the 1/n portfolio. So therefore, we want the location of the index name 1/n. All right. Okay. Maybe, or, oh yeah, we need the idiosyncratic risk because we also want to have a plot. Idiosyncratic risk, you see that we have it. Inf-op idiosync risk. Okay, what's idiosyncratic risk? It's nothing else than total risk minus systematic risk. Okay? So therefore here, just, I don't want to use too much copy and paste. Although, of course, that is tempting, but I think it's good practice for coding. Code yourself. Inf-op systematic risk. Okay, awesome. I should have copy pasted it. Inf-op, idiosyncratic risk, total risk, systematic risk. Total punct risk is a key error. Total punct. I know, I mean, I don't, it's a bit small for me. Maybe I need glasses. Oh yeah, there was maybe some change, I don't know, and then maybe systematic. Okay. Oh, maybe I didn't press? No, I did. What's the matter here? Okay, something I forgot to execute. Okay, now let's just give me the inf op. Let's just have a look. Okay, great. So you see that, for example, there's total risk here. You just, okay, I don't have the ratios here, which one could do, easier for interpretation. Just go for the beta. Adidas has a 0.7 beta. What are the big beta firms? That is a 1, 2, 3 beta, a 1.5 beta. 1.3 beta. Right, so you see it's hard to get a beta which is below 0.58. That's the lowest I spotted. Which might be BNP Paribas. It's a bank with a low beta, relatively speaking, low beta. You have the ING bank, which has a 3 times as large beta. If the CAPM was correct, then that should pay a risk premium 3 times as large as BNP Paribas. I don't think they do. Right? If you look at that thing here, BNP, if that's BNP, but at least it's this ticker which I'm looking at, it's 7% mean return, and ING is even lower. Yeah, ING lost 2 decades. So we know CAPM has some problems, but maybe it's not the CAPM which has a problem, but from a data perspective, it's just we mismeasure the betas. There's research in that direction supporting that point. All right. So what we now do is we're going to provide plots, but in another video, where we provide exactly that plot, but the x-axis will be systematic risk, it will be the beta, and it will be idiosyncratic risk. And then we see whether the low vol anomaly holds across all risk measures that I came across. Stay tuned.